Okay, so the last video I think got cut off right before I said the answer for this example number 12, and there it is, 1/5 arcsecant, and there's the bell, that's nice, of absolute value of 2x over 5 plus c. So I know there's a couple more problems that you can do as exercises, check Canvas. I also want to look at example 15 because this one's going to need completing the square, which love it. It's completing the square, it's calculus, it's an inverse trig function. I mean, you cannot get much better than that, which is really cool. I know, I'm a little excited about that. So, how do I know that this is going to be completing the square? Well, look at the denominator. There's nothing about that for a u that would make sense as an entirety to call u because this derivative wouldn't be sitting on top. There's no way to call just this x squared a u without having this x, let alone this 13 as well. The last piece, I guess, from algebra, there's no way to combine a quadratic term and a linear term unless you think about it as a group. So I want to do just a little bit of algebra first. X squared minus 6x, and push that 13 aside. Let's complete the square of the denominator first. And again, just kind of review, x squared minus 6x, we would really have liked a plus 9 to complete that square. So we'll go ahead and subtract 9 to keep it balanced. And so now I have x minus 3 squared plus, and look how nice that was, 4. So that's equivalent to my denominator. So I'm going to rewrite my integral like this. So I'm going to take the antiderivative of dx divided by quantity x minus 3 squared plus 4. And so now it fits that structure. It's a sum of squares. I have something squared plus something squared. And that's characteristic of arctangent. And that's the final one. Okay, excellent. So I'm going to let this be my u. I'm going to let u equal x minus 3. And I'm not sure if I necessarily need a u substitution because the derivative is just dx. But at least I'm seeing it as a placeholder. So if that were a 2x, obviously I'd have a chain rule. But again, I have something squared, and something is x minus 3. And in this case, my a is equal to 2. So this is characteristic again of arctangent. Arctangent is 1 over a, so a was 2, so 1/2. Arctangent of u, which is x minus 3, over a, which is 2, plus c. So in this example, I sort of talked through a step that I did in the other ones, but I didn't write it. I was saying 1 over a, arctangent u over a, plus c, and then I was also substituting as I went. Okay, example 16, which I think might be the last example, is going to require another completing the square. Except for this time I also have bounds of -5 to 4, so I'm going to actually also be finding the area under this curve. Off to the side, I might do a little bit of algebra first, again, completing the square, x squared plus 10x, and this is plus 106. So I might be thinking, okay, half of 10 is 5, 5 squared is 25, so we'll take away 25, probably not the best color to choose, minus 25, there we go. And so then when I rewrite this integral, so I have from -5 to 4 of dx over, now this part groups up to x minus 5 squared plus, and then 106 minus 25 would give me 81, which, wow, how nice is that? Don't panic if that's not always a perfect square. It doesn't have to be. And even sometimes when I want it to be, I make a mistake, and so you wouldn't get a perfect square, and that's okay. It wouldn't be a Mr. Brown test or a quiz without a mistake somewhere. But at least here, again, I have my u, and I think it's good that we do write our u. Our du is equal just dx. But in this case, I think it's good we write our u, because now I can change my bounds and just write this completely in terms of u. And here my a value is equal to 9. So this is a characteristic shape, structure I should say, of arctangent. So arctangent, so it's I have the integral of 1 over u squared plus 9 squared du. And let's go ahead and change those bounds. So if I do, oh, wow. I wish you guys could you're probably yelling at me through the computer saying, typo, mistake. That's x plus 5. Silly Mr. Brown, because x squared plus 10x plus 25 factors to x plus 5. X plus 5. That makes me feel really good, because negative 5 plus 5 for my u, that'll change that to a 0, and 4 plus 5 will change that to a 9. Phew, otherwise, I don't know what I would have done. Okay, so this is arctangent, and remember for arctangent, it is 1 over a for your starting coefficient. So we have 1/9 arctangent of u, which I don't even care about what was before because everything was substituted out, over a, which is 9, when evaluated from 0 to 9. And 0 to 9 actually are going to be really nice values for this particular one, because when I put 1/9, and I'll just leave that factored out, arctangent of 9 over 9, which is 1, minus arctangent of 0 over 9, 0. I should know this. They'll expect you to know this on the AP exam. I expect you to know this in Mr. Brown's, BC class. Arctan of 1, remember we've already talked about the restriction. There's only one principal root, is positive, quadrant 1, pi fourths. So 1/9 pi fourths, and same thing with tangent, 0. So we get pi 36, which kind of is a very kind of crazy answer, I think. Pi 36 is the amount of area that's sitting under this rational function, which seems to have nothing to do with a circle, yet a lot of times when we think about area of circles, it's like pi r squared, which is reminiscent of that value. Okay, so again, just another example of inverse trig. You should complete all of these problems in your note sheet, check Canvas, and then obviously do the homework, and then see questions with me for, if you have questions, see me in the morning.